Hello everyone, my name is Prakyan and today I will be presenting my project on predicting gold price trends where I analyze 10 years of historical data from 2013 to 2023 using time series forecasting technique. So this project is a part of my coursework for data mining for competitive advantage. Now let's begin. So here's a quick overview of today's presentation. We will start with an introduction and background research, followed by the problem statement, data acquisition and data exploration. We will then move into the stationary check, forecasting model, model evaluation, residual diagnosis, and finally we will summarize our findings. Gold. Gold has long held a unique position in global financial market, valued not only for its physical properties but also for its role as a financial asset. Its price is influenced by complex interplay of factors including supply and demand dynamics, global macroeconomics conditions, geopolitical tensions, inflation rates, interest rates, and investor psychology. Historically, gold has been considered as a safe haven asset, meaning that during the period of market volatility or economic uncertainty, investor tends to invest gold to preserve their wealth. The objective of the project is to systematically analyze gold price movements over the last decade from 2013 to 2023 and develop a predictive framework using time series analysis technique. Through Through this, we aim to understand the underlying pattern and improve the ability to forecast future gold prices, a task which is highly relevant for investor, policymaker, and financial analysts. So, during my research, I studied a significant global events that affect the gold price, which includes Brexit in 2016, the COVID-19 pandemic in 2020, and Russia-Ukraine war starting at 2022, and the banking crisis in 2023. All of these events create a noticeable shift in the gold price behavior. Core problem statement is very simple. How accurately can we forecast gold price movements using historical time series data? This helps investors and policymakers to anticipate market behavior during uncertain times. So for the data acquisition, I source daily gold price from publicly available financial dataset, which is known as Kaggle. The time span from 2013 through 2023 provide a rich data set for building and evaluating forecasting models. Data exploration and visualization. So in data exploration and visualization phase, I analyze trends using 100-day and 200-day moving average. Uh, I also highlighted the key global events like Brexit, COVID-19 pandemic, and recent banking crisis that introduce a major fluctuation in gold prices, which you will see in the next slide. The second visualization further highlight the impact of major world events on gold prices. These geopolitical and economic shocks constantly repeat the gold role as a safe haven asset during the time of global uncertainty. So before building any forecasting model, it is very critical to check if the time series is stationary or not. A stationary time series has a constant mean variation and autocorrelation structure over time. This stability makes it easier to model and forecast accurately. To test for stationary, I use the augmented Dickey-Fuller test. In this case, the ADF test statistic was minus 3.1412 and p-value was about 0.05135, which is slightly higher than the standard 0.05 threshold. The result indicate that the gold price series is close to non-stationary. There is a mild trend present in the data, but it's not extreme. Since the ARIMA model can handle non stationary data, especially when differencing is applied, it is appropriate to proceed with modeling after differencing the series once. Forecasting model ARIMA. So to forecast the gold prices, I applied an ARIMA model, which stand for autoregressive integrated moving average. ARIMA models are widely used for time series forecasting because they are flexible and powerful in capturing different patterns in data. The model is characterized by three parameters: autoregressive, integrated, and moving average. The autoregressive part captures the relationship between an observation and its previous observation. Integrated part represents differencing the data to make it stationary. Moving averages part models the relationship between an observation and past forecast errors. For this project, the best fitting model was ARIMA, which essentially behave like a random walk. This configuration means there are no autoregressive terms and no moving average term, just one level of differencing to stabilize the series. The forecast produced by ARIMA appears relatively flat, with predictions centered around the last observed value. The shaded area in the plot represent 80% and 95% confidence interval, and we can see they widen over time, indicating greater uncertainty as the forecast horizon extends. While simple, the ARIMA model provides a strong and interpretable baseline, particularly when the underlying series shows a minimal trend or seasonality after differencing. So, this slide presents the naive forecasting method where future value are assumed to be equal to the last observed value. So you can see that the blue line shows the forecast while the yellow line shows the actual gold price during the last 30 days. The shaded blue area represents the confidence interval around the forecast by observing how closely the forecast follows the actual price. We can see that the naive method performs reasonably well in the short term. So now comparing model comparison, ARIMA and naive forecasting. Comparing two models, although their RMSE values are similar, the ARIMA model achieves significantly lower MASE value. This suggests that ARIMA offers better overall forecasting performance while the naive model is still strong. Baseline, it lacks error scaling efficiency. Therefore, ARIMA is recommended by most consistent and reliable future forecasting. Uh, so here we'll look at the residual diagnosis for ARIMA model. The residual are randomly scattered around 0. The ACF shows no significant lags and distribution is approximately normal. This suggests that the ARIMA model fits the data well and meet the assumption for residual behavior. So on the other hand, residual from the naive model shows slight pattern and ACF plot indicates the mild autocorrelation at some lags. The residual distribution also deviates slightly from normality, meaning the naive model does not perform as cleanly as ARIMA. At last, to summarize, I analyzed 10 year of gold price data using the time series forecasting technique. Major global events such as Brexit, COVID-19 pandemic, and the Russia-Ukraine war and the banking crisis significantly impacted the gold price. ARIMA model provided the best short-term forecasting performance, showing the lower error matrix and better residual behavior as compared to the naive method. So at last we can say that the overall time series analysis proves to be a very powerful tool for understanding the forecasting of gold price trends. Thank you.